MPLS Layer 3 VPN, which we started previously. We are going to continue today. Layer 3 VPN is nothing but routing. That's why it is Layer 3. The routes are advertised from the customer side into the provider's router. Provider's router take those routes, advertise it through a specific virtual link called VPN, which is nothing but encapsulation. Using this encapsulation, the packet gets delivered to the remote provider edge. From the remote provider edge, it gets decapsulated and delivered to the remote customer. Let me repeat what I said with a diagram. You got customer edge, customer edge 2. These are two different sites. In between, you got a service provider. The service provider has got multiple routers. Many routers. And these routers are connected. It can be a mesh topology or it can be partial mesh or it can be serially connected. We don't know. What VPN provides is a virtual tunnel between this router to this router. So now what happens? The customer advertises some network through this purple link and it gets delivered into one of the routing table here, a purple routing table, which is created using VRF, virtual routing and forwarding. And now from the routing table, the routes get placed into the VPN. It goes to the other end and gets downloaded to the purple routing table here. And from this routing table, the route goes to the customer edge. This is what I said. We call it as layer 3 VPN. The route advertisement coming from CE1 is learned only on the PE1 and PE2. PE1 learns it through the direct link connected to the CE1. This is what I called as PE1. PE1 directly learns from the physical link. PE2 learns from the virtual link called VPN into this VRF kept for customer. And from the VRF table, the route is taken and given out over this physical link and gets delivered to this CE2. So if you will have 1111 network, you will see that in the routing table of CE2. So now CE2 members can ping 11111. So why VPN? If you don't have VPN, then all these routers in the core need to learn the customer's network. One big difficulty is if I have more customers, then thousands and lakhs and millions of routes. All router cannot accommodate that much in the routing table. Every inside routers have got some limitation. Even the PE routers, even though they are big ASR devices, they also have some limitation. But PE routers are big routers. They can handle more than the internal core routers. So you cannot give more route updates to the inside routers. That's one reason why we need to have this VPN. Secondly, provider learning all the routes of the customer is not safe for customer. If provider's routes are seen in the customer's routing table and customer's routes are seen in the provider's routing table, then it is dangerous for both of them. If there is a bad customer, he will come inside provider's network and spoil provider. If provider is bad, then he is going to spoil the customer's business by getting into customer's network. So to isolate the customer's traffic and the provider's traffic, to isolate the customer's network from the provider network, we take the route into a separate routing table, not mixing with the same routing table where the provider's route is. We call that separate routing table as VRF, a separate routing table. And that separate routing table, the non-default routing table, is what attached to this VPN. The default routing table is attached to the physical link. The PE1 and PE2 VRF is attached to VPN. VPN is provided using the BGP peering. In BGP, we have VPN v4 feature. Using that feature, we can negotiate BGP tunnel between provider edge 1 and provider edge 2. Once the tunnel comes, we will take the customer route and give it inside the tunnel if customer is having different protocol. If customer is advertising using OSPF, then you have to take it and put it into BGP because the tunnel is made up of BGP. But if the customer is running BGP, if the customer is also running BGP and you have eBGP between the customer and the provider, all the routes coming from the route advertisement coming from the customer will be automatically placed inside the tunnel. You no need to redistribute because both are BGP. Tunnel is also BGP. Customer and the provider is also eBGP. So in our first lab, we will have BGP on the customer side. And then after understanding how BGP works, we will change some other protocol on the customer side. Other protocol like OSPF on one side, EIGRP on the other side, RIP on other side, ISI is on other side, like that. Yeah, so I'm going to now get into the lab environment, which we have already selected for this, and we'll start doing lab now. First, I'll bring all these devices inside the ISP, enable OSPF so that there will be reachability between R3 and R6 loopback. Using that reachability, we can negotiate VPN. R3 should reach R6 first. For that, we use OSPF. So I'm going to put OSPF in area 100. Okay, these are all fresh routers with no configuration. IP OSPF 1 area 100. You see, OSPF is running only on this loopback and the LAN side, only on F00. I'm not running OSPF on G3/0 and G4/0. We are not running any IGP protocol outside this autonomous system. So router 6 is ready. Show IP OSPF interface brief. I should see IP address and the area properly configured. Next is router 5. I'm going to start using Notepad so that I can save some time. If I do any mistake in typing, please let me know. This goes on router 5. So next is router 4. You're right. Okay, so I must be now pinging, able to reach from 3 to 6. Ping 6.6.6.6 source. It is pinging. So using this reachability, I can negotiate VPN. I'm going to have BGP router BGP 10. Listen here carefully. Address family VPN v4 unicast neighbor 6.6.6.6 remote AS. Okay, so what we need to do is, first of all, we need to define the neighbor outside the address family. So neighbor is 6.6.6.6, remote AS is 10, neighbor is 6.6.6.6, update source loopback 0, and then I need to say address family VPN v4. See, we are trying to form VPN, so it should be VPN v4. Address family VPN v4 unicast neighbor 6.6.6.6 activate. Simple, activate, because you have already declared as neighbor. So you are just coming inside and saying that neighbor should be VPN neighbor also. That neighbor which is configured outside VPN is now also part of VPN. This command will simply form IBGP. It will not form VPN. We are saying that IBGP needs to be a VPN. That's all. Now to verify this, show BGP VPN v4 unicast VRF all or unicast all summary. It says so far no negotiation of VPN. This is to verify VPN. Simply to verify IBGP, show IP BGP summary. See the difference. Here it says so far no negotiation happened because I don't know where this fellow 6.6.VPN is. First of all, it needs to be IBGP, no? Then only it can negotiate VPN. IBGP itself has not come. How the VPN can negotiate? See, the output looks somewhat similar, not somewhat similar, mostly similar. Major sections are similar, except
What is the difference? What is the difference of the two command?
this is simply to find the neighbor status. This is to find the VPN status with that neighbor. This is simply to check IBGP and EBGP neighbor. This command. This command for those neighbors, what is the VPN status? First of all, the neighbor should come, only then the VPN can come. Neighbor itself is not up, it is idle. The neighbor itself has never come. So the VPN also will not get negotiated, will not come. Now when I finish the IBGP configuration from R6 towards R3, then both will come up. Neighbor will come up and then the VPN will come up. First, let us go and configure only IBGP on R6, not the VPN, and then we'll come back and see the difference. I'm going to R6. In R6, I'm going to say router BGP10, neighbor 3333, remote AS10, neighbor 3333, update source Lubag 0. So if you now see on the other side, the output will be slightly different. You see, VPN is no negotiate so far, but this neighborship has come. The neighborship has come, but the VPN is not negotiated. Why? Because the other side is not ready yet. R6 we have not configured address family VPN v4. Let us sniff packet and see what it shows here. IBGP is already good. It's going to have keep alive only. You see, these are all keep alive messages. IBGP is good between 3333 and 6666. But there is no VPN. Clear IPBGP VPN v4 unicast all unicast. There is no BGP thing we see, only the keep alive we see. Okay, now let us go and configure the other side, then we'll come back and see. Here I'm going to say address family VPN v4 unicast. Neighbor is 3333. You know, one mistake I have done is I have not enabled MPLS so far. Alright, I have not enabled MPLS. Okay, now I am having the configuration on either side for the VPN, and VPN has come up. Session 2. You see? Neighbor 333, session 2 is up. Session 2 is VPN session. And for that VPN, the open message update, all are sent. I don't see anything in the update. The reason is we don't have MPLS. Actually, MPLS will be sending update um, using the labels. Alright, so nothing here. The second session has come. What is next? So on all these four routers, we are going to run MPLS. That's the second step I'm doing. See, third step. This is the third step we are doing. First step is we have enabled OSPF with the IP address. Second is we formed IBGP and then we negotiated VPN v4. So now if I type show IP, sorry, not IP, show BGP, VPN v4 unicast all summary, you should see VPN also up. And if I type simply show IP BGP summary, this is normal neighbor. Neighbor came long back. VPN came just now. Yeah. So you see in neighbor there are a lot of messages compared to VPN. VPN we brought the VPN up few seconds before. So VPN is up and MPLS is what I'm going to put now. Before that I want to show you Ceph table. Show IP Ceph for 6.6.6.6/32. See, there is no label, and router 3 says next up is router 4. There is no label. Why I'm showing 6.6.6.6? With that only we are going to form. With that only we have already formed a tunnel, and we are going to send the updates with the label for customer. For the customer routes, there will be label. But those labels will not be seen in router 4 and 5. For the customer routes, labels will be seen only on 3 and 6 because it goes through the VPN. So far, we don't have any customer's route. Let us enable MPLS here, then we'll go to customer. MPLS IP interface F0/0 MPLS. Likewise on R4, that's it. Now we have MPLS on all these routers. Now I'll go back to R3 and I want to check this F table and I can see a label number assigned. So MPLS is running, but we don't have any VPN traffic. VPN traffic will come from the customer. We don't have any customer now. Let's bring the customer. Today I'm going to finish only the customer which is on the top, Tinku in the left and Tinku on the right. Tinku in the left is running BGP Autonomous System 100. Tinku on right is running BGP 200. What is Tinku? I don't know. And down, if you see, there is another customer called Binku. I don't know who is this Tinku and Binku. It's some imaginary name. It's imaginary name. Okay. Let us go to Tinku now and configure IP address and BGP. Now on R3 and R6, I have not configured G3/0. On R3 and R6, I have not configured G3/0. I have not. The reason is those interfaces are currently in global routing table. But we have to take this interface and give it to a routing table which I'll be configuring for this customer Tinku using VRF. So when you configure an interface inside VRF, if there is any configuration already present like IP address, they will get removed. That's why I did not put any IP address because it will get removed later. I will create a VRF, then assign an interface to that VRF, after which I'll give IP address. Only then it will stay. If you give IP address now, later when I put this interface to the VRF table, the IP address that I configure now will get removed then. Okay, now finish Tinku configuration, then we'll go to the edge routers. Enable config t host name Tinku left. Tinku left has got interface loopback 0 with IP address 1.1.1.1, 255.255.255.255, and interface G3/0, IP address 13.13.13.1/24. And we decided to run BGP here, so I say router BGP 100. The network that I want to advertise is 1111, mask is 255. Then the neighbor will be router 3. Router 3's address is 13.13.13.3. Remote AS is 10. So this neighbor need to be configured. So far router 3 is not configured with this IP address. I'll be configuring this IP address on G3/0 of router 3. Okay, you don't need to mention anything extra here, nothing about VRF, nothing about VPN because this is customer side. Customer side, as usual, he will be sending packets. Now what is next is...
But I have mentioned about that remote IS10.
Ask.
Remote IS10 is router 3.
Yeah, ISP's autonomous system. 10 only we have written here, right? You see. Welcome. So similar to this configuration, R2 need to be configured. So I'm on R2. Enable config t host name Tingo on the right. Interface loopback 0 IP address is 2.2.2.2. And then interface G3/0 26.26.26.2. This is the WAN side of Tinku customer on the right, and the mask is 255.255.255.0. Now we say router BGP 200, neighbor is 26.26.26.6. This is going to be the address on router 6 G3/0. Remote ASS router 6 is also in autonomous system 10. The network that I want to advertise from this Tinku on the right is done. Now the customers are ready. Only on the provider side now you need to find some way to create a routing table for the customer. We need to create a routing table for the customer. And then allocate an interface that connects to the customer to VRF, to that routing table. So I'm going to create a VRF and allocate G3/0 of router 3. Same also on router 6. And then form EBGP with the customer. I'll do from router 3. See, before I configure that, I want to show you something. Have a close look. Show run section router BGP. Now, do you see anything called address family IPv4 VRF? Not VPN v4. Do you see anything like address family IPv4? No. But you see what happens when I create VRF. Start with IP command. IPVRF Tinku left. Route distinguisher. You see, you can put IP address of the customer and the autonomous system number of the customer, or autonomous system and some number, or you can simply put 1:1. It's nothing. 32-bit colon 32-bit. So I just put 1:1 to identify this routing table of Tinku L. Now all that this customer is going to give, I need to export it. So I say route target export. I'm giving same value, but it is not mandatory to give same value. And if router 2 advertises something to router 6 will also export with the same value. So I need to say route target import 1:1. See, this all need not to be same on this. You need not to match RD with RT, but to make it simple, this is the first round of doing this lab. So Let me put the foundation strong so I'm not complicating things. Now, what I'll do on router 6 is I'll configure VRF for same customer. You see, IPVRF, Tinku. This side I'm saying right. You see, the name is not same. Here I said L. Here I said R, which means name need not to match. That you one part you understood. Second thing is route distinguisher. Here I'm going to give 26.26.26.2, which is the IP address of router 2 colon the autonomous system number of router 2. See, this is not mandatory. So now you understand the route distinguisher also locally significant that need not to match on either side. But what's supposed to match is route target. For both import and export, we use the same value. So I can say 1 colon 1. If you don't say export or import, if you don't say export or import, it is going to take 1 colon 1 for both. Now I want to show you in the running configuration. Show run section IPVRF. You see, I did not say import and export. It is taken automatically as import and export. Let me put the same command on the other router and show you the differences in the configuration that we have made. You see, the name is not same. Yeah, the name is not same. The route distinguisher is not same. This export should match with this import down here, and this export should match with this import up here. But in our case, both import and export are same, so there is no confusion in that. What is next? I was telling you that when you see the BGP table now, do you see anything like IPVRF? No, there is no IPv4 VRF. But as soon as I assign interface G3/0 to that VRF Tinku, IPVRF forwarding for Tinku L. As soon as I do this and put an IP address here, what is the IP address? 13 13 13 3 255.255.255.0. All right, now you see I need to say one more thing. Router BGP 10 address family IPv4 VRF Tinku L unicast. Okay, Tinku L neighbor. So I'm going inside this routing table of Tinku, and I'm saying neighbor is 13 13 13 1. Remote AS will work here. In this address, in VPN address family, remote AS will not work. You need to create outside and activate. But inside the IPv4 VRF, you should configure. Remote AS is 100. That's all. And you will see now neighbor coming up. Neighbor come. Neighbor come. Why the neighbor has not come? Let us check the routing table first. Show IP route VRF Tinku hyphen L. The routing table don't have a root, which means I have not brought the interface up. Let's check this. Show IP interface brief. The interface is shut down. Show IP VRF. You see, in VRF we have assigned interface, and we have even put the IP address. Those things are good, but I have not said interface to come up. Now let us verify once again. The neighbor will come up. Show, see the neighbor has come up. You can see that. No? BGP neighbor using VPN VRF Tinku L is up. So eBGP neighbor has come up.
Okay.
Yes.
What is the difference between service label and VPN label?
Yeah, service label is the label. Both are same. Okay, now let us verify something. Show IP BGP summary. You don't see eBGP. Why? This is the BGP that is showing only those under the default routing table. So if you want to see the VPN routing table, sorry, VPN neighbor, show BGP, VPN v4, unicast, all summary. Now you can see that these two guys are attached here. The external guy is attached to the internal VPN v4 guy. This proves that how the customer is connected to the VPN. This is how customer and VPN gets connected. You know, I was putting the command VPN v4. This is a VPN neighbor, not the normal IBGP. It's a VPN neighbor, and this is an eBGP neighbor.
Hello?
Yes, yes.
But in router 2, we didn't configure, how do you call it?
BGP, we already configured.
Okay.
Now I'm going to router 6. On router 6, I'm going to say interface G3/0, no shared IP address is 26.26.26.6 255.255.0 IPVRF for, first I should assign VRF forwarding, then IP address. Anyway, I did a mistake. First, you should not type IP address. First, you assign it to the VRF. Okay, let's put it. VRF forwarding Tinku-R. Now it says the IP address will be removed. No problem. I can put it back. Okay. So what we have is show IP VRF. We have the interface assigned. Now, if you want to ping from here to the customer, you cannot ping with the routing table, which is default. You should ping with VRF Tinku R, and then you say 26.26.26.2. Now the ping will happen. If you ping without VRF, it will try to source it with the global routing table. Global routing table is no way connected to the customer on the right. Okay, anyway, now what I want to do is I want to do BGP with Tinku on the right. So I go to router BGP 10. Address family IPv4 VRF Tinku hyphen R. Neighbor is 26.26.26.2. Remote AS is 200. Now you will see neighbor coming. The neighbor has come up. Via VPN, VRF, Tinku are up. Now if you see, R1 will know about R2. You see, show IP route. Look at this. You learned 2.2.2.2. Let us trace the route. Trace route to 2.2.2.2 with a source of 1.1.1.1. You will see a lot of labels. You will see two label and then two label and then one label and then no label. Meaning from router 3 to router 4 it will go with two labels. From router 4 to router 5 it will go with two labels. Router 5 will remove the transport label and then router 6 will remove the service label and then it will go out. You see now 3 is sending to 4. You will see two labels. Come on. Yeah, you see two labels. One is 18, another one is 21. And then 21 is the VPN label, service label. 18 is the label to reach 6666. Now, according to router 5, 19 is the label to reach 6666. And there will be only 21 in the next. See, 21 is the VPN label, which is service label. And router 6 will remove the 21 and send a simple IP packet. Router 6 will remove even that label now. Goes to router 2. Boom. So we stop